This video is part 2. Please ensure you've watched part 1 before watching this one. Part 1 looked at grouping division in the context of a bowling alley and thinking about how many lanes could be set up with different numbers of bowling pins. The aims of this video will be to extend the strategies that we looked at in part 1, to explore how these can help us solve division problems that involve grouping with larger numbers. We'll explore this in the context of the bowling alley again. Remember that one bowling lane needs 10 pins at the start of the game, so there is a 1 to 10 relationship between the bowling lane and the number of pins needed to start. In part 1 we looked at how many lanes we could set up if we had 100 bowling pins. Pause the video and see if you can figure out the answer. You may remember this from before, or you might need to use a strategy to work it out. There are lots of ways that you could figure out the answer to this, but whatever way you used, you will hopefully have worked out that if there were 100 bowling pins, there will be 10 lanes. As an equation it looks like this: 100 divided by 10 equals 10. And you might have made connections to your multiplication facts if you know that 10 lots of 10 is 100. So what if you had 110 bowling pins? We still need 10 bowling pins per lane to start the game. So how many lanes would you be able to set up then? Pause the video and try to figure this out before continuing. As always, there are many ways we might have worked this out, including skip counting or using facts that you already know. We'll look at one strategy here. Compare it to your own, thinking about the advantages and disadvantages between your strategy and this strategy. You might have thought about facts you already know. We've already seen that 100 bowling pins will create 10 lanes, either because we know that 10 groups of 10 is 100, or because we know that 100 divided into groups of 10 will give us 10 groups. We can now see that because we had 110 bowling pins, we've got one more group of 10. This will mean that we can set up one more lane. Again, we might have connected this with facts we already know. I might know that one group of 10 is 10, or that 10 divided into a group of 10 will mean that we have just one group. So we can see that if we had 110 bowling pins, and there are 10 bowling pins per lane, then this would mean that we would be able to set up 11 lanes. If we try to put all that information together to think about what that might look like as an equation with a division symbol, it looks like this. We know that 100 bowling pins divided into groups of 10 created 10 lanes. 100 divided by 10 equals 10. We also know that 10 bowling pins divided into groups of 10 created one lane. 10 divided by 10 equals 1. So if we think about what that looks like as one equation rather than two, we had 110 bowling pins altogether. We divided them into groups of 10 because we needed 10 pins in each lane, and this created 11 groups of 10, which means that we would be able to set up 11 lanes. 110 divided by 10 equals 11. What if you had 150 bowling pins? We still need 10 bowling pins per lane to start the game. So how many lanes would you be able to set up then? Pause the video and try to figure it out before continuing. We'll look at two strategies for how you might have worked this out. Compare your strategy to each one and think about the advantages and disadvantages. You might have thought about facts you already know again, and known that 100 of the bowling pins would mean that you could set up 10 lanes, because you know that 100 divided by 10 is 10, or that 10 groups of 10 is 100. Then you might have counted in groups of 10 from there. So if 100 creates 10 lanes, then 110 pins would be one more lane, so this would be 11 lanes. 120 pins would be 12 lanes. 130 pins would be 13 lanes. 140 pins would be 14 lanes. And so 150 pins would be 15 lanes. So if there were 150 bowling pins and 10 pins are needed in each lane, you'll be able to set up 15 lanes. Another way you might have solved this is thinking about combinations of known facts that you have. For example, you might have known that 100 pins would create 10 lanes, either because we know that 10 groups of 10 is 100, or because we know that 100 divided into groups of 10 will give us 10 groups. You might have also known that the remaining 50 pins would create another 5 lanes, either because we know that 5 groups of 10 is 50, or because we know that 50 divided into groups of 10 will give us 5 groups. So we can see that if we had 150 bowling pins and there are 10 bowling pins per lane, this would mean that we could set up 15 lanes. If we try to put all that information together to think about what that might look like as an equation with a division symbol, it looks like this. We know that 100 bowling pins divided into groups of 10 created 10 lanes. 100 divided by 10 equals 10. We know that 50 bowling pins divided into groups of 10 created 5 lanes. 50 divided by 10 equals 5. So if we think about what that looks like as one equation rather than two, we had 150 bowling pins all together. We divided them into groups of 10 because we needed 10 pins in each lane. And this created 15 groups of 10, which means that we would be able to set up 15 lanes. 150 divided by 10 equals 15. We'll do one final example. What if you had 200 bowling pins? We still need 10 bowling pins per lane to start the game. So how many lanes would you be able to set up then? Pause the video and try to figure this out before continuing. Again, there are different ways you might have solved this, but you might have thought about the 200 bowling pins being 2 groups of 100 bowling pins. We already know that each group of 100 pins would create 10 lanes because of our knowledge of multiplication or division facts. 10 times 10 equals 100, or 100 divided by 10 equals 10. So if we've got another 100 pins, there will be another 10 lanes that we can set up. So if we've got 200 bowling pins, still with 10 bowling pins per lane, we'll be able to set up 20 lanes now. Again, if we try to put all that information together to think about what this might look like as an equation with a division symbol, it looks like this. We know that 100 bowling pins divided into groups of 10 created 10 lanes. 100 divided by 10 equals 10. Then if we've got another 100 bowling pins divided into groups of 10, this would be another 10 lanes. 100 divided by 10 equals 10. So if we think about what this looks like as one equation rather than two, we had 200 bowling pins all together. We divided them into groups of 10 because we needed 10 pins in each lane. And this created 20 groups of 10, which means that we'd be able to set up 20 lanes. 200 divided by 10 equals 20. So hopefully that's given you some ideas about strategies that you might be able to use to help you solve division problems involving groups of 10 when larger numbers are involved.